Welcome to The Explainer. Hey, if you've ever had an AI just hit a wall when a task gets a little too complicated, then this one's for you. Today, we're going to break down a really powerful design pattern that gets us way beyond a single lone wolf AI. We're going to learn how to build an AI dream team. So here's the game plan. We'll start by looking at exactly where a single agent falls short. Then we'll introduce the solution, this multi-agent approach, and its whole management structure. After that, we'll see it in action with a really clear software development example, and we'll wrap up by unpacking why this pattern is a total game changer. All right, let's dive in. To really get why we need a team in the first place, we have to start with a problem. The basic limits of a single AI agent trying to do it all on its own. You know, we have this idea of AI as one big, all-powerful brain. But what happens when a problem gets really complex and stretches across totally different areas? It's kind of like asking a brilliant poet to also be a world-class coder and a financial analyst. The specialization just isn't there, and things start to break down. And this slide lays out the difference perfectly. On the left, you've got that one agent trying to juggle everything. It gets stuck, it gets brittle, and the more complex things get, the more errors you see. But look at the right. The multi-agent system works like a killer engineering team. It breaks the big goal down into smaller chunks and hands each piece to the specialist who's built for that exact job. So, how do we get past that limit? Simple. We build a team. And in the world of AI, this is called the multi-agent collaboration pattern. This is how we build that AI dream team. And here's the big idea. Instead of one generalist, you create a whole crew of specialized agents that know how to work together. The whole thing really hinges on one core principle: task decomposition. You take a huge, high-level goal and you slice it up into small, manageable jobs for your specialists. Now, every good team needs a leader, right? A project manager. In this pattern, that's the orchestrator. This is the central agent that holds the big picture. It understands the final goal, and its job is to break that goal down into a smart plan and delegate the work. And who does the orchestrator delegate to? To its team of experts, of course. These are the worker agents. Each worker is a specialist, fine-tuned for one specific thing. You might have a researcher agent that's amazing at digging up information, a writer agent, or maybe a coder agent that knows one programming language inside and out. Each one is a master of its craft. Okay, so let's get into how this team actually communicates, because this isn't just a free-for-all. It's a really clear hierarchy that makes the whole workflow structured and, more importantly, predictable. The workflow is actually pretty elegant and logical. It's really just a three-step dance. First, delegation. The orchestrator breaks down the goal and hands out the assignments. Second, execution. Each worker goes off and does its thing. And third, synthesis. The workers report back with their results, and the orchestrator pulls it all together into one final coherent package. And this quote right here, it nails the most critical job of the orchestrator. It's not just handing out tasks. The real magic is in that final synthesis step, where it intelligently combines all the different pieces from its specialists into a final result that is way better than the sum of its parts. Okay, that's the theory, but let's make this really concrete. We're going to walk through a use case that pretty much any developer is going to recognize: building a brand new software feature from scratch. So, the whole thing kicks off with the orchestrator acting like a product manager. It gets the main goal: implement a new user profile page. Right away, it breaks this down into the core engineering tasks. You've got back-end logic, front-end UI, and of course testing. Then it assigns each of those jobs to a specialized worker agent. Now the specialists get to work. And notice, there's a sequence here. First, the back-end agent has to write the server-side code and API. Once that's done, it reports back. Then the front-end agent can jump in and build the interface that uses that new API. Finally, once both pieces are in place, a specialized test engineer agent runs all the tests to make sure everything works together, and it reports those results back up. And once all the specialists have reported back, the orchestrator does its final and most critical job: synthesis. It takes the back-end code, the front-end code, and the good test results, and it integrates them all into a single, complete, totally deployable software feature. Done. So, we've seen it in action. Now let's just zoom out for a second and summarize the key advantages that make this whole pattern such a powerful way to build complex AI systems. The benefits here are huge. First, you get higher quality work because of specialization. Second, you reduce complexity, which makes the whole system so much easier to design, debug, and just maintain in general. You can even have agents work in parallel at the same time, which can slash your execution time. And you can even get a kind of simulated brainstorming session where different agents approach the problem from different angles. Ultimately, this is all about bringing real engineering discipline to building AI. Like the slide says, it turns a messy, unreliable request into a structured, managed process. This is how you go from a fragile AI prototype to a robust system that you can actually put into production. So you can see this pattern is way more than just a technical diagram. It's a totally new way to think about problem solving with AI. It lets us move from simple little tasks to tackling truly massive challenges. And that leaves us with a really interesting question to think about. If you could build an AI dream team for any problem at all, what's the first big thing you'd have it solve?